This is our week 2 vlog, and my name is William, and my partner's name is Abeer. We are doing Project 9B, and our research title is a qualitative study of CNN optimizers with weight decay, where we will be comparing the loss landscape with different optimizers and varying amounts of weight decay. For week 2, we have found our dataset called Human Faces from Kaggle.com. It contains 5,000 images of real human faces and 5,000 images of AI generated faces. We then used this dataset to train a CNN. The CNN was designed for binary image classification on input RGB images resized to 64 by 64 pixels, which contained of two main parts, feature extractor and a classifier.
So since we trained the model and used the same dataset to test them, there was a 0% margin of error. And we implemented the Adam optimizer in our code using the inbuilt PyTorch class to train the CNN on the dataset. We did this separately for the two different models, one with the weight decay and one without the weight decay. We did this to ensure controlled comparisons in the loss landscape visualization. So overall, our task this week was to change different hyperparameters and study the effects on the loss function. Study the effects of the loss function. Hyperparameters include batch size, which is the number of samples used for each gradient descent update, the learning rate, which is how big of a step each gradient descent update takes, and the weight decay, which in our case is the L2 regularization.
Then we plotted two graphs, initial versus final parameters and weight decay versus no weight decay. The graphs are plotted using a one-dimensional linear interpolation approach, and this was a parameterized function changing the value of a variable alpha from 0 to 1, where 0 meant the output was fully 100% one set of parameters, theta, and 1 meant the output was 100% another set of parameters, theta prime. Changing the value of alpha between 0 and 1 controlled the ratio between theta and theta prime. We set theta and theta prime to be our initial and final parameters with the loss function on the y-axis, and this allowed us to visualize the loss landscape between the starting and finishing parameters. This is what one-dimensional linear interpolation is.
So for the next week, week 3, our task will be moving on from an analysis analyzing changing hyperparameters to exploring the behavior of the loss landscape with the varying amounts of weight decay around local minima where the model converges. We will be observing the loss behavior, flatness or sharpness of the minima, which in essence is how flat or how steep the area around the minima is, and the overall area of the local minima to see how similar the minima is to a real CNN image classifier. So that's it for week 2. Thank you.
Thank you.